Hi everyone, I'm back again. I'm here to record LeetCode problem number 380. Insert, delete, get random, O of 1. So let's get started. The problem wants you to implement the randomized set class. Randomized set initializes the randomized set object. Bool insert in val inserts an item val into the set if not present. Returns true if the item was not present, false otherwise. Bool remove int val removes an item val from the set if present. Returns true if the item was present, false otherwise. Int get random returns a random element from the current set of elements. It's guaranteed that at least one element exists when this method is called. Each element must have the same probability of being returned. You must implement the functions of the class such that each function works in average O of 1 time complexity. So basically what's going on is that you're given a set of operations, and there's 3 of them: insert, remove, and randomize, as well as a particular value if the value exists. And you're basically, this is the output, but the important thing is that, you get your functions working so that you get the correct output. But you have to implement the functions in O of 1 time. So that's the trick to it all. And let's just quickly look at the constraints and the topic. So the constraint is the values themselves can be anywhere from as low as -2 to the 31st to as high as 2 to the 31st minus 1. Let's take a look at this constraint. At most, 2 times 10 to the 5th calls will be made to insert, remove, and get random. So that means that you can have a crazy high number of calls if you needed to make them. And of course, the operations are insert, remove, and get random. There will be at least one element in the data structure where GetRandom is called, so you have to implement GetRandom. And let's take a look at the topic. I think this is an array problem, but let's take a look at the topic themselves. So this is an array, hash table, math, design, or randomized problem. So this is an array, hash table, math, design, or randomized problem. So the first time I did this problem, I didn't care about time complexity. I just solved the problem. And what made sense to me is that, the insert method is very easy to implement. If the value is not in, so you define a randomized set, and if the value is not in the randomized set, then you append it, return true, otherwise you return false. With remove, it's if the value is in the randomized set, then you remove it, return true, and return false. And with GetRandom, you use a random number generator to generate a random index between 0 and n, and then return, actually 0 and n minus 1 inclusive, and then you return the randomized set at that particular index. Otherwise, can't return a value. So right here, this right here, I believe this not in and in operations that come native to Python is O of n. So this is not O of 1. So let's take a look at the O of 1 solution that we're going to do right now. So the first thing you need to do is define two different data structures. So you do a self dot ind equals hash table, a hash dictionary, self dot values equals a list. So what's going on right here? We're going to solve this problem this way. Let me give you an example right now. So let's say this was the example. We did the insert operation of 1. We did the insert operation of 2, and we did the insert operation of 3. So what do we have in our list? We have 1, 2, and 3. So self.values list, and this is what we're going to do for the indices. We're going to do self.ind equals the dictionary, and so what we're going to do is, so 1 is going to be mapped to 0, 2 is going to be mapped to 1, and 3 is going to be mapped to 2. Essentially what's going on is that the values themselves are going to be the keys. The values in the list are going to be the keys, and their index, right? Their index is going to be the values, right? The key value pair. So the values in the list are the keys, and the index of each value is going to be the second part of the pair of the key value pair in the indices. This way, once we have these two data structures, that helps to facilitate the O of 1 operation. It helps to do things in O of 1 because looking up things in the dictionary is O of 1, and removing from the list is also O of 1. So let's take a look at how we do this, right? So the insert function is going to work like this, right? Let's write the algorithm. If val is in self.ind, then return false. The reason you return false is because you can only insert the item into the val. You can only insert item val into the set if not present. Okay. Then what you do is you basically, after the first check, you know that you can insert the value. So you do, if val is in self.ind, then return false, then you do append val to values, right? And then what we're going to do is update self.ind for val such that its index is the value where val is the key. This may seem a little confusing. Let's do it. If val is in self.ind, return false. You do self dot values dot append val. Then you do self dot end of val equals len self dot values -1. Okay. Now let's take a look at the approach for remove. So the approach for remove is the following. Get the index I for val from the list self.end. So then once we get the index I, this is where it gets a little crazy. We know the index for the value of I. So the first thing we're going to do is we're going to so the first thing we're going to do is get the index I for value from the list self.end, right? Well, we're just going to say get the index I for val, right? Then what we're going to do is set the index of the last entry in val to have index I. Then what we're going to do is set the value of the entry in set the value of the entry in the list at index I to be the last entry. Then the fourth thing that we're going to do is delete the entry for val in the indices dictionary and delete the last value from the list, from the list. So essentially what you're doing is you are let's say you have to delete number 2. So you copy 3 here, you move 3 over here, right? And then right, so basically if you were to delete 2, the first thing you would do is change 3 in the indices list so that it has the index of this value that you're deleting. And then the second thing that you do is you're copying this value over to where you want to delete, wherever, so that you have a space for delete. Then once it's copied over to wherever the value is being deleted, then you can terminate that value from the index array and then pop the last value from the list. It's a 4-step process, but it's actually genius. And so the last thing we need to do is do a check. If val is not in self.end, then return false, right? The value is not in the index dictionary, then you can't delete it. And this is an O of 1 operation. This is an O of 1 check because it's a dictionary. So let's do it. Self.end val. So then you do set the self.end values -1 equal to I. Set the value of the entry in the list at index I to the last entry. So self dot set the value of the entry in the list. Self dot values at index I to be the last entry equal to self dot values of -1. And so this is the two delete operations. Self.end dot pop of val. And then you remove the last entry from the list. Self dot values dot pop and return true. And the last function is very easy. You just do a canned function. Return randomize dot choice of self dot values. Let me take a look at all this. If val is in the self.end, then return false. Self.values dot append val self.end of val equals length of self.values -1. Okay. If val is not in self.end, return false. I equals self.end val self.end self.values -1 equals I. Self.values I equals self.values -1. Okay, that makes sense. Self.end.pop self.values.pop. And let's see. If val isn't self.end, yeah, that seems to be right. In, not is in. In. Randomized is not defined. Random, not randomized. Let me take a look. This should return true. Forgot return true right here. Okay. Submit it. Okay, and that works. This is the time complexity is O of 1, obviously. The space complexity is O of n, where n is what you're passing in, the number of values that you're passing in. Okay. There were some tricks here. I felt this was a very tricky problem, but you know, it's always worth practicing and always worth getting better. The more you practice, the more you get better. So I just have to keep going. Thank you.